Hello student, myself Nimesh Prabhakar. Welcome to Antenna and Propagation lecture series. In this lecture, we will discuss about the antenna parameter. Then next one, we discuss about the classification of antenna. In my last lecture, I discussed about the introduction of antenna. Now we start this lecture. So first one, we discuss about the antenna parameter. So here we understand what is the importance of antenna parameter. Why we study the antenna parameter? So first we start. There are some properties of antenna and we should have knowledge of it. This will be useful when we want to select antenna for particular application. Also, this property can be used for comparison between different antenna. So, like I will give you one example so you will understand better. So, I want to design one antenna for GPS system, GPS navigation system. So here I want define the parameter for this antenna. Like I have to define the gain of this antenna. First of all, I have to define the frequency range of that antenna. Then I design the antenna. Or we can understand from the second one example. Like you want to receive the dish TV signal. So you go to buy the antenna. So you have to define, I want an antenna with specific range, like this frequency range antenna I require. I also require antenna gain is 6 dB or 7 dB. So these are the parameters. Like whenever we go to buy the mobile phone, so we define our mobile phone. I want a mobile phone with the 6 GB RAM. Then I also define like processor speed and megapixel of the camera. So these are the antenna parameter. So now, which are the parameter? So these are the parameter of the antenna, like bandwidth, beamwidth, frequency range, gain, polarization, then beam efficiency, then directivity, radiation intensity, and the radiation pattern. So these are the parameters of the antenna that we will discuss in detail in the chapter number 2, the antenna parameters. Now we discuss the second one topic of this lecture. So the classification of the antenna. So antenna is broadly classified in 3 categories. First one is based on the isotropic, directional and omnidirectional radiator. So this is the first one classification base. Now second one is classified in the base of resonant and non-resonant antenna. And the last one, third one is classified is the classification based on frequency range. So mainly these 3 base used to classify the antenna. First one is the isotropic, directional and omnidirectional antenna. Then second one is the resonant and non-resonant antenna. And third one classification is based on the frequency range. So now we start with the first one classification. So first we understand the isotropic radiator, or we can say isotropic antenna. So what is isotropic antenna? An isotropic radiator is a hypothetical radiator which radiates equal amount in all directions. So this is a hypothetical radiator. That means in a practical this type of antenna is not possible. So this is a hypothetical radiator which radiates its radiation in all directions equally. Like this is the one point source you can consider, and it radiates its energy in all directions equally. The example of isotropic radiator is point source. So you can see this is a point source and it radiates its energy in all directions equally. Now the radiation pattern of the isotropic antenna you can see here. This is the radiation pattern of the isotropic antenna. It's just like a sphere. It radiates all energy equally in all the directions. So the radiation pattern of the isotropic antenna is just like a sphere. It is used as a reference antenna to determine the directive properties of particular practical antenna. So in a practical use, we use the isotropic antenna for define or we can determine the directive properties of the practical antenna. So this is the isotropic antenna and this is the radiation pattern of the isotropic antenna. Now we discuss the second one, is the directional antenna. So see, this is the radiation pattern of the directional antenna. And now we understand the directional antenna. A directional radiator is an antenna which radiates or receives the electromagnetic radiation more effectively in one particular direction than other direction. So this is the antenna. You can see it radiates in particular one direction. This is the main beam of the antenna. It radiates in particular one direction and suppress the other beam of the antenna. So this is the property of directional antenna. We can say it radiates in a particular one direction. An example of the directional antenna we can say that is a dipole antenna, horn antenna, paraboloid antenna, or we can also say the Yakuda antenna. So these are the example of the directional antenna. Now we see the third one type of the antenna is the omnidirectional radiator. So an omnidirectional radiator is an antenna which has a non-directional pattern in azimuth and direction but directional pattern in elevation plane. So here this is the radiation pattern of the omnidirectional radiator or the omnidirectional antenna. So here you can see this is the radiation pattern. The non-directional pattern in the azimuth direction, or we can say in the azimuth, and directional pattern in the elevation plane. So this is the difference between the omnidirectional antenna and isotropic antenna. Isotropic antenna radiate equally in all directions. You can see this is not radiate equally in all directions. Now example of the omnidirectional antenna we understand. So first one example is the circular loop antenna. Now second one is the vertical Hertz antenna, Macroni antenna, and this is the radiation pattern of the omnidirectional antenna. So here you can see this is the horizontal plane radiation pattern. It radiates equally in the all direction in the horizontal plane. But you can see this is the vertical plane of the radiation pattern. So it is not radiate in equally in a vertical plane. So it's like a directional pattern in the vertical plane. And horizontal plane you can see it radiate equal amount energy in all the direction. Now we discuss the comparison, or we can say this is a difference between the isotropic, directional and omnidirectional radiator. So first one you can see this is the directional antenna, then next one is the omnidirectional antenna, and the last one is the isotropic antenna. So here this is the radiation pattern difference you can understand. First, we understand the isotropic antenna radiation pattern. So the isotropic antenna radiation pattern is the radiate equal amount of energy in the all the direction. You can see this is the isotropic antenna radiation pattern. Now, second one is the omnidirectional radiation. So here you can see it not radiate equal amount of energy or the radiation in all the direction. You can see in this figure. And last one is the directional antenna. That means it radiates its energy in particular one direction. So this is the directional antenna. So this is the comparison between the isotropic antenna, omnidirectional antenna and directional antenna. Now we see this next one is a classification of antenna is based on the resonant and non-resonant antenna. So first one we understand what is the resonant antenna and what are the properties of the resonant antenna. So the resonant antenna are the antenna with a length in the exact multiple of lambda by 2. So here the antenna length is measured in terms of the lambda. We know lambda is equal to C by F. F is our the frequency and C is the 3 into 10 raised to 8. So we can find the lambda value. So the resonant antenna are the antennas with the length in the exact multiple of the lambda by 2. Now the such antenna open at both the end and none of the end is terminate in any resistance. So this is the second one property of the antenna. You can see this antenna is open at both the end and none of the end is terminate in a resistance. Now third one property, they operate at the fixed frequency. That means one particular frequency is defined for this antenna. Like we use antenna for particular one application only. That means I use this antenna for the 1.1 gigahertz. So I receive only 1.1 gigahertz frequency by using this antenna. So this is the property. They operate, or we can say it operates at a fixed frequency. Next one property, reflected and standing wave axis. So here in the radiation pattern, or we can say in the receiving or the transmitting side, the reflected and the standing wave is axis in this antenna. The voltage and current along the length are not in phase. So this is the next one property. The voltage that we apply and the current is not along the length in the phase. So phase is a change. The radiation pattern of such antenna is multidirectional. So here this antenna radiation pattern is multidirectional. So it radiates the energy in a different direction. So that's why it's known as the multidirectional radiation pattern of this antenna. And last one is such antenna is known as the periodic antenna. So this is the resonant antenna property. Now we discuss about the non-resonant antenna. So the non-resonant antenna are traveling wave antenna with a length other than multiple of lambda by 2. So here the wavelength, or we can say the length of the antenna is other than lambda by 2. So not in the terms of the lambda by 2. If the antenna is in the terms of the lambda by 2, then it's known as the resonant antenna. But other than lambda by 2, then we can say that antenna as the non-resonant antenna. Now next one. Such antenna excited at one end while other end is terminated into characteristic impedance. In the resonant antenna, we know in the resonant antenna both the end is open, but here one end is terminated and into the characteristic impedance. Now next one property, they operate over a wide band of frequency. So this is the main characteristic of the non-resonant antenna. It operates over a wide band of frequency range. So we can use for the wide frequency band range application, like for the particular L band, S band or C band, we can use this type of antenna because it covers all frequency range like 1 to 2 gigahertz, 2 to 4 gigahertz. So this is they operate over the wide band of frequency. Now next one is there are no reflected wave and hence no standing wave in this antenna. In the resonant antenna, we know the reflected and standing wave is present, but here there is no reflection, so that's why there is no standing wave is present in this antenna. Now next one is the voltage and current along the line are not in phase. So here the voltage and current of this antenna is not in the phase. Now next one is the radiation pattern is unidirectional. So this is the property. In the resonant antenna, the radiation pattern of the antenna is directional. But here the radiation pattern of the antenna is the unidirectional. And such antenna is known as the aperiodic antenna. And we know that in the resonant antenna is known as the periodic antenna. But this antenna is known as the aperiodic antenna. So this is the classification based on the resonant and non-resonant antenna. Now, last one classification based on the frequency range. So according to the different frequency range, we know that very low frequency, high frequency, ultra high frequency, they are used according to the application range. Like first one we can say this is the VLF, is known as the very low frequency range. The range of the frequency is between the 3 to 30 kilohertz, and this type of antenna is used in the telegraphic application. Now next one is the LF, that means low frequency band. The frequency range is 30 to 300 kilohertz, and the application of this antenna is used for the navigational and the marine aids. Now next one, third one is the MF, that means the medium frequency, and this the frequency range is between the 300 kilohertz to 3 megahertz, and this is used for the AM broadcast and the navigational purpose. Now next one is the HF. HF, that is high frequency range, and the frequency range is the 3 to 30 megahertz and used for the short wave broadcasting. Now next one frequency range is the VHF, very high frequency, and the range of frequency is between the 30 to 300 megahertz and it used for the FM broadcast, like we listen the radio FM broadcast, then it also used for the television and the radar purpose. Next one is the VHF, that is the ultra high frequency, and the frequency range is between the 300 megahertz and 3 gigahertz, and it used for the application is the short distance communication. And last one is the microwave frequency, and the range is the 3 to 330 gigahertz. It is used for the radar, satellite communication. So this is the classification of antenna based on the frequency range. So in this lecture, first we discussed about the antenna parameters, then we discussed about the classification of the antenna. So here we discussed about the two topics of the antenna parameter and classification of antenna. Now in the next lecture, we will discuss about the types of antenna. Thank you.